everyone. My name is Zach Harris. I'm with Prodim USA, and I want to welcome you guys to the Prodim Canvas webinar today. In today's webinar, we're going to be going over digital templating and patterning a full boat enclosure from A to Z, going from 3D to 2D with the Proliner Canvas Package. Before we start the webinar today, I just want to go over questions. Feel free to type any questions that you guys may have. I will try to address all of them at the end of the webinar. All right, so when we're going to go over today is, again, digital templating and patterning for this enclosure in these upcoming videos. There's going to be 4 main steps that we're going over. So there's fixing the frame, measuring the frame and the parts with the Proliner, doing some templating to the design like adding extra windows and zipper marks, and then finally flattening it, taking the model that you've created from 3D back to 2D in RhinoCAD. So step 1 of the process is to fix the frame. So to do this, you need to determine the correct height that the frame is going to sit when the canvas is installed in it. And you want to make sure that the frame stays in the position while you're measuring to make sure that there's no movement, so you get accurate measurements. You also want to mark the points that you want to measure. So a little pre-working ahead of time helps you know exactly where you want to measure to, helps you execute the measurement better. And you also want to indicate any places on the vessel or the object that the canvas will protrude or overhang. So I'm going to go to our first video here. This is my colleague Nikki setting up the Proliner with the tripod in the boat that we're going to be measuring the enclosure for. So you see the Proliner comes with a backpack and a tripod. It's nice and portable to bring to the job site, any marina, the dock, wherever the boat's located. And now you'll see Nikki using what we call the Prodim Tensor set. This is a new accessory that we offer that helps you position the frame to where it needs to be. And this is, some people may use tape or like webbing to do this, but these are nice and adjustable to help you get the frame in the correct position. Just make it a little bit easier on you. We now offer this along with the canvas package. As you see here, he's just doing some adjustments, making sure it's in the correct position where the canvas again is going to lay when he's actually doing the measuring process. Just taking some initial measurements there. To make sure it's sitting wherever he wants it to be. And now he's going to mark the points where he's going to measure on the actual frame itself. And another key to this component is you really want to mark where the seam is going to lie on the frame itself. That's really going to give you the most accurate position of where the frame is, and when you're doing your model, so the seams line up and you get the best pattern as possible. And doing just this little bit of extra work in the beginning before you take your measurement really helps everything go nice and smooth, and really creates for a better measuring experience as well as a better drawing at the end. And now he's taking some blue tape, with some painter's tape, and just marking where the canvas is going to come off the bow down to the side of the vessel there. Sorry about that. And again, marking his points, this again ensures that you know exactly where you're going to be measuring. next slide here. So we're going to move over to step 2 here. Step 2 is to do the actual measuring of the frame and the parts of the boat. So this is where we're going to make sure we place the Proliner in a stable position. Make sure you can reach all the points that you want to take from one position. The Proliner also has a built-in leap function, so if you can't reach all the points from one position, you do have the opportunity to reposition the machine as many times as needed to get everything in the same file by using the leap function, which is a very simple function on the Proliner. We're also going to select the correct pen settings because there's a couple different options of pens that the Proliner Canvas Package offers, so you can get all those points accurately and easily. And also we're going to work with different colors and different layers here, so it's easy to differentiate the which part of the boat is which.
Yeah. Start tomorrow. Yes.
So Nicky, now he's going to do a little bit of a drawing here just to kind of visualize what he wants this enclosure to look like. So this is never a bad idea, coming in and just doing a little bit of, thoughts in your head and just make something that you want the finished product to look like, and just quickly mocking something up so he knows what he's got to do. And that, you see, that's the goal that we're going for this enclosure here. So there's a couple windows on the sides, a window in the back, and some flaps down there, and he's drawing in the zippers now. Again, the finished product there. All right, he's setting up the tripod in the back of the boat. We're gonna place the Proliner on the tripod, make sure it's nice and stable and it's snug on the tripod so it's not moving at all while you're measuring. The Proliner is a very portable measuring device. It's powered either by battery, or if there's power available at the job site, you can plug the Proliner into power. It's all ran nice and easily on a touchscreen interface, so it makes it easy to type in the job names and work around on the machine itself to get a nice large screen. So he's just naming the project and the actual measurement, and then he's going to select the type of pen that he wants to use. In this case, he's going to be using the hook pen of the Proliner. And the hook pen is what you'll see he's attaching to the Proliner arm at the moment. Is a cool tool that we have in the Proliner Canvas Package that allows you to get around the frame of bimneys or even over the edges of the vessels, just to get you a little more flexibility in reaching the points. So the first thing that he's going to do is he's going to set 3 points to just basically show where the horizon is. So when you bring this model into RhinoCAD, you don't have to do a lot of orienting the drawing because it's already come out in a nice horizontal view for you. Now he's going to come and going to template the frame itself. And he's just taking multiple points on the frame, and you see the hook pen actually goes around and allows for him to get around the frame. And you want to be, again, marking the top of the frame where the seam is lying. That's always going to give you your most accurate product at the end. And you see why it was important now to put the pieces of tape there, and also to add your extra points, just so he had a good game plan. He knows where he was going to be measuring, and as you see here, you get a nice clean file of the two parts of that frame there, as well as those 3 points that he took for the our horizontal or our horizon measurement. And now he's going to measure the actual part of the boat there, the whole of the boat, just to get that where that ends. So that's an important part of our measurement. He's also utilizing the hook pen for that. Then it's going to come up and measure the windshield, because it's going to snap up to the windshield. And he's going to follow that all the way back around to the other side. Now you see we have the bulk of the measurement there, right there on the Proliner. It's nice and easy for you to rotate the screen and visualize what you have going on. And now he's also now colored each layer a different color, so it's easier to visualize what is what. And then when we bring it into RhinoCAD, we already have an understanding of what layer is what color means this. So. All right, we're gonna move over to step 3 now. So step 3 is the templating of the design. So this is where you want to add all the additional stuff. So we've already measured the frame and the boat itself. Now we need to measure some additional points on the boat, the snap locations, where we want to put our windows at, where we're gonna have some seams maybe, and then where we want our zippers to be. That's all gonna be done in this step. We're going to use some blue tape again to visualize where these seams or these zipper locations might be. This is always a good practice, so it just makes the measuring part way easier, and when you get into CAD, everything's there ready for you. And you need to determine how far the canvas is going to go down. We're going to show that in this step, and then of course we're going to mark all the snap locations, any of the studs, fasteners that are there. And we're also going to be using the IPT because there's going to be some points that are really hard to reach. So let's play the video. All right, so now Nikki's going to take that blue tape down, and he's going to use some new blue tape to mark where his window locations are going to be. And this can simply be done by taking a tape measure, just visualizing where you want the tops of the windows to go. One of the things that we like to really preach in measuring in the training portion of this is to do as much setup as you possibly can before you measure, because this helps you visualize the job and makes everything a lot easier. And we've got that taped up, and as you can see, these are the window shapes that we're going for. And now he's going to add an additional piece of tape because there needs to be some sort of a seam there, because again, canvas behaves in different ways, and you have to know how the canvas is going to fall from the top of the frame to reach the back of the boat. And there's going to be, to really take away the slack off the back there would need to be an additional seam there to make everything nice and fit. And here we go again, we're marking our points where we need to measure. We also added an additional piece of tape in the back there for zipper locations, because there's going to be 2 zippers in the back there for easy access into the boat when the enclosure is installed. So still using the hook pen, Nikki's going to take points on the frame where he marked on the pieces of tape as well, to mark where the windows are going to be. And then he's going to go do that same thing on the other side. Just want to talk about the hook pen again. It's a really great tool on the canvas package, because without it, it'd be hard to do a lot of the measuring. There's a lot of locations that are a little tricky to get to on, especially for marine canvas. As you see now, we have a new layer in purple there to show our zipper marks, the seams in the back, as well as where our windows are going to be. And now he's going to take down the frame. We already got the frame measurement, so it's not important to have that up anymore. This is going to make it a little easier on him to get the rest of the measurement. And we're going to change from the hook pin back to the standard pointer pin, is what you see that he's attaching now. And we're going to talk about the IPT. So IPT stands for Inverted Pen Technology. And that's what Nikki is putting together at the moment. And what the IPT helps with is it helps you get to hard to reach points like the hook pin, but it gives you a little more range because there's the longer lengths that are available. As you see, the Proliner always measures to the tip of the pen that the wire is attached to. But when using the IPT, we can tell the Proliner we're using this new pen setting, and by measuring in this special method of making a sort of cross or sphere in 3D space, it'll actually project the measurement from the top of the pen, pointer where the measurement is usually taking all the way down to the bottom where he is touching on these fasteners. And that projects that point exactly to that marking space. And this is how he's easily going to be able to go around and mark all our snap locations, as well as get to the point on the vessel where the canvas is actually going to lie. You see here on the windshield, marking the fastener. IPT just gives you a lot more flexibility when measuring for these things without having to leap. So you're going to notice, I talked about the leap earlier, but the leap was not required for measuring this enclosure. And now you see we have all our snap points are colored in green here. Now he's going to put some blue tape there and mark where we want the canvas to end. This is really nice. As you can see, he's taking a piece of blue tape, and because there's a transition from the hull to the windshield, so you want to kind of catch that transition. So when you're taking this measurement, when you bring it back into RhinoCAD, it's nice and easy to model. You're not left guessing with some really random and crazy lines there. They may not line up, or you may not remember what happened. So now he's just using the IPT again and measuring a couple points on the gunnel cap there. Gonna take one extra point along there just to show how far out it goes. That's never a bad thing. The more points, the better in some cases. And now we're gonna mark the blue tape that he set aside to capture the curvature of the hole going up to the windshield. Again, doing this all with the IPT makes life a lot easier on the Proliner operator. Going across the windshield, going through the other side. Some parts that weren't shown here is measuring on the back of the boat. There's a little axis flap down there that you see in yellow and a couple snaps down at the bottom. We're kind of zooming in on it at the moment, but he also used the IPT to get back down there. Do a little rotate just to make sure that we got everything. This is sort of like a final check while you're on the boat, just to go around and make sure that everything that you needed to get measured was measured. And as you see here, this is going to be a short preview of what these measurements are going to look like on the boat. And then finally, we're going to bring it into RhinoCAD in our next step, and we're going to actually model the enclosure and then create that model to go from 3D back to 2D. So now, once you're done with the file, we want to transfer it out. The Proliner X series have Bluetooth capability, so you can download the Proliner File Transfer app on the Google Play Store and transfer the files directly from the Proliner via Bluetooth to your smartphone, or you can transfer them via USB and export out the DXF files in to be modeled in RhinoCAD. And that's going to lead us to step 4. Step 4 is bringing the model in 3D from the Proliner and then flattening it back out in 2D in Rhino and adding all of our, we're going to add our all our snap marks, our zippers, our windows. We're going to even show how to add some tension or some slack in the 2D patterns, and also make reinforcement patches, make our seam allowance, and also our notch tags or our seam markers, and to create a production ready file to go to your Prodim plotter or a CNC cutting machine. So let's start the video. So we're opening the drawing in RhinoCAD. Most of you guys are familiar with Rhino. If not, it's really nice 3D CAD software. Most of the marine industry uses this for modeling. And now the first step here is to align our measurements. So we did those first 3 points while measuring to show the horizon, which it brought the drawing in as straight as possible, but sometimes there's a little bit of alignment to be done. But this is a very important part of the step, so you're looking at the measurement correctly, and everything is rotated in the correct orientation, so it's not confusing to you or confusing to anybody else that would be working on it. So the second step is to now intersect our lines, and as you see over on the right, we've made some layer list of the different layers that we're going to be working on, and now we're just using the curve extend tool to extend our curves till they meet to the other curves that we want them to connect to. So simply by using the curve extend, you click on the end of the curve and you extend it to an apparent intersection of the curve that you're eventually going to attach it to. And we're working this in a temporary layer here, and that temporary layer is then going to be deleted because we're adding this cool feature here is we're adding, it's called closest point. And what this does is when you measure things in 3D, it doesn't always line up just because of the deviation created by the pen of the Proliner and just how things are in the real world. So we have to have these things connected to make a proper 3D pattern. So to do that, this closest point tool allows you to select a target curve, and then it will snap a point on that target curve. So then you can click and drag the curve that you want to attach to it to that correct point. Very useful tool when connecting all your lines so you can make clean surfaces. Makes this step really easy because if everything's not attached, then there's no way you're going to make a clean surface. So we're just going to continue connecting the stuff, all of our curves here. Again, we're going to use curve extend tool, extend it till it meets the bottom curve there, and then we're going to bring this one back up, essentially trimming it up to that same location. Snap our zipper markers there. Now we made all those temporary points to attach those to. Oh, we missed a couple. We need to attach our window lines to the bimini frame. You see we can just simply click and drag using the closest point. Again, one of my favorite commands in Rhino for doing this process. Really makes life easy. And now we're going to select everything in that temporary layer and delete it because we just made those points for reference to attach all that stuff. They're not going to be needed for the rest of the process. So the next step is we now need to create surfaces that can go over our measured curves here. So we just need to do a little bit of splitting of some of our lines here to make sure we create a surface that is suitable for what we need to put our material over. And we're using, to create this surface, the loft command. And using the loft command, you only need to select 2 curves and it'll loft a surface between the 2 curves. And when you do that, you'll notice that we're also rebuilding that surface as we go. You can choose how many control points that you want to add when you do the loft. What that does is it will allow you to, instead of cleaning the lines up like using curve interpolation or rebuilding the curve, it'll actually clean up the surface as you add it to the object. So you see here we're rebuilding it with 7 control points, and now our vertices on our surfaces line up with each other. And that's really, really important when making 3D surfaces like this that are going to come back together in a 2D pattern. Again, we're just going to finish the lofting there. As you see again, the vertices line up nice and good, nice and formal with each other. Step 4 in this process is now to project all the lines that we've created for our snap points, and as well as our window markers. We need to project those points to the surface that we created. So we use the pull curve command, and you simply just select the curve or the points that you want, and then you right click, you hit enter, and then select the surface that you want to pull the curves to. It then projects those curves onto the surface. So now that you can, when we flatten these surfaces, those curves will be in the flattened product as well. So now we can easily rebuild our windows and know where our snap locations are for when we mark it on our plotter or our CNC cutter. Just want to add, these are our zipper lines that we're going to attach to the back panel there. And now, since we're done with, we don't need any of the curves of the actual frame anymore. We just really want to work with the surfaces that we created, as well as all the projected points that we created, our snaps and our zipper locations and our window locations. We can simply take all that information, move it away from the original frame. So we're just now working with the surface. And this is the part that is really integral in the process. All of it is, but this is the unrolling of these actual 3D pieces and bringing them back to 2D. So what we're doing here is we're basically just using the gumball tool to arrange these panels away from each other. And then we're actually also going to rotate them so they're all sort of facing down to the C-plane. So when they get flattened out, that's going to lead to a more accurate flattened product if they're all facing the correct direction that they want to go when they're getting flattened or unrolled below. It's very important that we do this. And now we're going to use unroll, and we're going to select the surface as well as all the projected points that we had there, our line for our seam up there, as well as our snaps. And as you see, we use the unroll tool and we put labels on it so we know that it flattened in the correct orientation. And we're going to do that with all of our pieces now. Those are our zipper marks for the top panel there. As they get flattened, it's really nice that you organize everything so everything looks like it's supposed to, so it's not confusing as you go on. making sure we mark our snap locations. As you see, this one actually was mirrored when it was flat, but not a big deal. You can easily arrange it and mirror it back to its correct orientation. That's why those labels come in very handy, so you know which face is which. Now we're gonna, since everything is flattened, the surface is still attached to the flattened pieces. So the next step is using the silhouette feature in Rhino. And what that'll do is it will make a border around each one of the pieces, just a curve of the outer border of the surfaces. And now we can come back and delete the surfaces. So we're just simply left with the curves to work with in 2D. So now we're going back to our, the 2D process in Rhino and adding all the extra stuff that we need to make these panels production ready for CNC or plotter. The next step, this step is very important. So in Rhino, there is a way, a lot of people, there's some other flattening softwares that are available out there, but that can do this step, and you can also do this in Rhino. So this, we're adding a 1/4 inch offset inside to add either tension or slack to these panels to make them fit nice and snug. So you don't have to add any darts. So this takes the darts out of the, or when most people in the manual process ask about darts, this is what we're doing here to alleviate that. And we're making a slight curvature. We offsetted it in a 1/4 inch and made a new curve to the center of that 1/4 inch offset, and then back out to the original point where it started to give it a slight curvature. So when we sew those pieces back together, they're nice and snug and makes everything form fit nice and tight. This is a very, very important step when making patterns, and this is really only needed in these two seams right here because of how the canvas behaves and it's flowing over from the back of the frame to the bottom of the bow. In our next step here, we're going to add reinforcement patches. So this is another important process to anywhere that you would need some reinforcement that the canvas is going to rub on some like a cleat or something, or just a lot of people like to double up on the bottom panel. So this is how we're going to add reinforcements, just basically making a copy here and selecting objects and offsetting them a little off to the side. In 2D, we can make our offsets. So we offset this like 2 inches in, or however big you want the reinforcement pockets to be. It's nice to make a copy of those because then you're not working with your original geometry, you're just simply working with the copied geometry, so you don't run the chance of messing anything up in the original. It's also not a bad idea to make copies as you go along with the process. As you see here, we're just trimming the 2D curves until they make our reinforcement patches. Again, just finishing this process up. While they finish this up, just want to let you guys know we offer full training on the measuring and the Rhino portions with the Proliner Canvas Package. So if you guys, if there's some existing users out there that need more training, feel free to contact us, and I'll give you our contact information at the end of the webinar. But also people looking into getting the package, if you guys, anybody is worried or scared about the CAD process, we are very knowledgeable in this, and we will make it very easy transition to go from zero CAD experience to understanding how to make a fully finished production ready cover. So here we're adding our zipper marks, and we made those in a different layer. It's going to be a green layer. Again, it's really important that we have our layers organized in different colors. Just it makes life a lot easier when you are measuring, or I mean when you're doing the patterning process, so you know what everything is. Right now we're actually making doing some offsets to make the pockets for the bars. We're going to then mirror those. So it follows the correct curve of the bar. Then simply just drawing 2D lines in to close the pocket up. Now we're just doing some aligning to align our pieces back to normal. And this is important for these two pieces because we're going to make windows together, and you're going to see that process now. So we already shot the top line of our window location there. So now we just need to come in here and we're offsetting lines in both directions, the same distance, whatever distance that you want it to be, 2-4 inches, whatever, maybe even higher. And this will give you your outer edges of the window. We're going to continue to offset these lines until we have everything offset. Then we'll use the trim function or the fillet function to come in, and we're actually going to use the fillet function here. You can put a tiny radius in there. Or you can leave it straight, however you want to produce your cover. Splitting the lines in the middle of the bimini there so we can easily fill it, and you'll see now the windows are taking shape. This CAD process is really pretty easy once you get the hang of it. Most enclosures and covers all follow the same steps, adding our windows and reinforcements, and of course the relaxation. And finally we're going to come and now we need to add our seams for our seam allowance, and we also need to make notch tags or alignment marks. So when we go to sew this together, all the pieces line up correctly. And those notch tag or alignment marks can be placed either plotted onto the material or, most of the time they would just be plotted onto the material either by our Prodim plotter or a CNC table. Now you can choose, most people would do a 1/2 inch seam allowance here. So we're just offsetting these lines that need the seam allowance a 1/2 inch to the outside. So we're essentially growing the thing by a 1/2 inch. Now what we're doing here is we're adding our alignment marks. So we're drawing a line perpendicular to the offset line, and we're going to use the array along curve tool to array that same line as many points as you want across that curve. So I think there we chose 9 times to go across, and we'll do the same on the corresponding panel. And what this will do is now it'll give us nice alignment marks when we put those two pieces together, and their seam allowances, they're lined up nice and easy for the sewer. And this is just dividing the curve based upon how many points that you want. Again, this is more alignment marks. So when you go to sew the pieces together, everything makes sense and it fits together perfectly like you wanted it. This is all controlled. Some people like a lot of points. Some people like very few points to align it, or just 3. And now finally you have a production ready file that you can make into your own sew map and send that DXF file out to either a Prodim plotter, and the Prodim plotter will allow you to plot those 2D patterns out onto the material. Look something like that. You see the Prodim plotter in action here. Or you can send these, if some of you guys that have CNC cutters, you can send it directly to the cutter and it's ready to go. Now the last step is just putting the cover together, sewing it together, and going and install it on the boat with a nice tight fit. So there it is, digital templating and patterning an enclosure with the Proliner Canvas Package utilizing Rhino. I want to thank you guys again for hanging out with me here, and I'm going to go, I got a couple questions here. I'm going to try and answer these while you guys are still here. The first one from Zachary was asking about the Prodim tensor set. So the frame, the tensor set is a very new accessory. These are to help mount the frame into the position that you want it to be. They are not included with the canvas package as it comes, but they're added as an extra accessory. We sell them for $210, same price as the Proliner tripod. Again, another question from Zachary. He asked, when connecting the lines, is there a tool or process that is run to check to make sure all the lines are connected and there are no dangles? Well, that is going to be, when you go to make a surface, it won't allow you to make a surface if the lines aren't connected in Rhino. So you'll find out at some point in the process that not everything's connected, and you'll have to go back in and connect them. But you can also use the split tool, and the split tool will help you do that before you go to the surface making step. The split tool will allow you to click on the line and split it with the line that you're hoping that is connected to. If it says the split failed, that means they're still not connected. But using the on-snap functions in Rhino will help you connect all those points together. Another question from William. He asked, when working with flooring, I have a curved area such as a fly bridge for some boats. How would you describe that process? There is an exaggerated arc on many of the boats I work on. I would like to 3D template them and flatten them out. The canvas seems to be much more complicated. Can you break down that process? William, if you would like, I can break down that process. I'm not going to do it on the webinar today, but I can go over that with you. It's actually a pretty simple process. It sort of uses the same things that we did here in Rhino, making a surface of the 3D space and flatten that back out. I would be happy to, one of our, or either our help desk here or myself would be happy to go over that process with you. It only takes a couple minutes. You can call into our office here. Our office number is 772-465-4000. Mike asks, what command was used to project the points onto the surfaces? That command is called pull curve. You can find that in, I think it's in the surface tools or it's in the curve tools. But again, Mike, you can feel free to give us a call. We can show you that one-on-one. Or you can send me an email. You can send an email to info@prodimusa.com, or you can give us a call, 772-465-4000. Yes, this presentation will be available to download. Or actually, we're going to have this presentation on YouTube. So this has been all recorded, and we're going to upload it to our YouTube channel so you can watch it forever. An anonymous, do you know how to make a grasshopper script in Rhino, and do lofts make poly surfaces? Can you flatten them? I personally don't know how to make grasshopper scripts, so not something that I have too much knowledge in. I know some people out there in the industry use it, and they do really well, but I would recommend just doing a little bit of research. Mike asks how much the Proliner Canvas Package is. Mike, please feel free to send me an email. I'll be glad to provide you with a quotation. Again, my email is info@prodimusa.com. Eric asks pros and cons of using squish versus unroll in Rhino. It sort of depends how the surface is behaving. Unroll usually, because as long as it's not a doubly curved surface, then you wouldn't necessarily need to use squish as much. Unroll usually, if it was one curving surface, unroll usually does the job very well. Zach asks, does Rhino include the Exact Flat plugin? Exact Flat is an additional flattening software. It's not part of our Canvas package. It is a plugin for Rhino, but not a part of the package that we offer. So all the tools that we're using in this video are all in Rhino. There was no additional flattening software included in here. Everything was done with the Proliner and Rhino. Eric, if you please email me, Eric, you can get this data. I don't mind. I can send this file over for you to practice with, and I can also give you some tips and tricks of what was done. And I could even send you can watch this presentation on YouTube later and try to go along with it. I did it myself, so it's not bad at all. William asked, how much is it to add basically a canvas package to the decking package? The decking package of the Proliner, I know there's a lot of guys out there that are watching this that also have the Proliner for marine flooring. The real only piece that you're missing is the hook pin attachment, because all the decking packages come with the IPT already, and the extra software. So it really just depends on what software or Proliner model that you have, and what software that you already have, if you have Rhino or not. But William, again, I can send you a separate email if you'd like to just shoot me an email or give me a call. I can update or provide you a quote to upgrade to the Canvas package. Mike asks, can Rhino handle compound curves? Yes, Rhino can handle compound curves, but it also has a flattening feature, unroll surface, undevelopable for those compound curves when they're curving in both directions. The only thing, you just have to either squish a way to do that, or squish the flattening command, or unroll surface UV, which is undevelopable, which helps with those compound shapes. An anonymous attendee asks how long the Proliner has been used. The Proliner's been around, the Proliner 8 series that was shown in the video has been out since about 2007. Then we've had previous model out since the early 2000s, so approaching 20 years or so on the market. And the Proliner's been used in the canvas industry. I've been with Prodim for 8 years, and it's well before my time. We have customers, I don't know, 10, 15 years using the Proliner in the canvas industry. Another question is, if we don't have the Prodim plotter, we can use a printer. So as long as you have, you definitely would want some sort of plotter or CNC cutter. We offer the Prodim plotter. Alexi, I can send you a quotation on that. If you want to send me an email with your email information. A printer doesn't necessarily work all the time because the size of the panels. It is a possibility, but it's better off going to a plotter or a CNC cutter. Jay asks, will the canvas package also work for marine decking? Yes, it will. The decking package is missing one component of the canvas package, while the canvas package entails everything. So if you went full bore and got the canvas package, you can do decking, no problem. Somebody asked how to account for the sag in the fabric. We did that in a portion of the video in the 2D drawing where we were offsetting the line 1/4 inch or smaller inward, and then drawing a curve to the center of that offset, and then trimming all the rest of that up so it actually creates a little curvature in the piece. So when they go to get sewed back together, it can account for that sag. So instead of making a dart, that's the best way to deal with that slack in the tension. Eric asked about the new tip for the pen. Just recently, our IPT, we came out with 2 additional tips. There's a sharp, or it comes with 3 tips now. There's a sharp tip there, as well as a tip that is the same as the ball on the pointer pen, and now a tip that's basically the reverse of the ball of the pen. So Eric, if you contact us, I can get you pricing if you want to add those to your current canvas package. Mike, I missed your question about exact flat for compound curves. If you want to contact me directly, I can show you some tips and tricks to do it directly in Rhino. So not all the time is a flattening software needed. So like especially with enclosures and covers like this, you can get the job done totally with the Proliner and just Rhino. I think I got to everybody's questions. If there's any other questions, guys, feel free to just send me an email. You can send it to info@prodimusa.com. They go all directly to myself. You can address them to Zach. And then you can also give me a call at 772-465-4000. I'm at extension 1. I'd be happy to answer any more of your questions. I'd be happy to set up extra demonstrations if you guys need additional training on existing Proliner packages that you have. You can contact me about that. We provide all that. We have lifetime support of the machine. I want to thank you guys again, though, for attending. I hope this was helpful and informational and showed you the real benefits what the Proliner Canvas Package and Rhino can do for making a digital enclosure. And thank you guys. You guys, hope you have a good rest of your day.